Good day. My name is Usman Etaaf, Sutura, a student from University of Ghana in level 300, and this is my semester end project for embedded systems and Internet of Things. This project is to solve two major problems for the Tema Metropolitan Assembly um, intersection. The first being that traffic light systems run at fixed timings, thereby sometimes leading to vehicle congestion and other times no vehicles at all. The second problem is street lights being on all the time without turning off, thereby leading to wastage of electricity, especially during the daytime. So I used a microcontroller Arduino system to make a solution for this. This has four subsystems. We have the street light systems, the street light system. Then I have the traffic light system. I have emergency button systems, and then also photoresistor system. Now, and a buzzer as well. Sorry, so the buzzer is the fourth one. Now, to start with my demonstrations for this project, I would first of all start with the traffic light. Now, when I run this simulation, we have states with the red state being state 0, green state is state um, 1, and then yellow state is state 2. Red runs for 5 seconds, green runs for 5 seconds, and then yellow runs for 2 seconds. When a vehicle is waiting, in order not to let them pile up to lead to congestion at red time, when it's a green and then a vehicle is waiting, we can push a vehicle detection button, which is over here, and then it extends the time for 5 seconds. So instead of running for 5 seconds, it runs for 10 seconds. Now, we also have a street light system. During the daytime, this street light would be off, and then during nighttime, this street light would be on. But how is this done? That's where this LDR comes in, light dependent resistor. So this resistor notices changes in light factors. For instance, when there's dim light, then it turns on the um, LED, and when it's bright light, it turns off the LED automatically. So to demonstrate this, so moving it to the left shows that there's dim light. So when I turn it to the left side, it means there's dim light or probably there's darkness covering this LDR. So it turns on the street light system for this white LED. And then during the daytime, when the sun comes out and we have bright light, then the component notices that there's light again, and it turns off the street light automatically. So that's what it does. And we also have emergency vehicle button as well. This button invalidates every other thing. So when I push it, the whole system comes to a halt with a buzzer beeping until I push it again to take it off of the emergency mode. So it could be the traffic light could be at green, it could be at yellow, it could be at red. Immediately I push it and then the buzzer sounds, unless we release it again for it to so as I've pushed it, it moves straight from green to red, and we have the buzzer sounding, and I release it again, and then the system goes back to normal functioning again with red, green, and then yellow. Now let's look at this. I've pushed it again. Now we have this. Let me go back and then push the vehicle detection button. This this would not affect anything because the emergency button is overriding everything. It's invalidating this vehicle detection button. So I'm pushing it, but then nothing is happening unless I take this off again, and now everything works back to normal again. Also, um, now I'll make combined scenarios using this system as well to show that it doesn't the subsystems doesn't block each other, or they don't override each other. So we have the traffic light system with the states showing, and we have the street light. So that's the first scenario. The first scenario would be dark conditions. So let's say it's in the night and we want to turn on the LDR, the street light, but then the traffic light system has to run as well. An emergency system should, and we can also push the emergency system button as well. So my traffic lights are running and the states are being recorded. Each state it moves to would be noted down. So for instance, it moves to state 2, which is yellow. It moves to state 0, which is red. Now it's daytime now. Let's say the sun goes down and we now get nighttime, and immediately the street light lights up. So now it's still like night time and our street light is lighted up perfectly. Our traffic light is still working. Let's push the emergency button to see if the buzzer and then the other system works as well. So we push the emergency button and then the buzzer is working. Our street light is still on and the traffic light system has not come to a red. Then we take it off and it shows the emergency system is cleared and everything is resuming back to normal. So this first scenario shows three things, three different subsystems working together. How we got to this, the street light lighting up, at which part would it light up and at which part would it go off. So I calculated a threshold which would show daytime and then nighttime. So I used the extreme, and which is 1015 for daytime. That's when it's the darkest, and then 8 for when it's the brightest. And we have 8 here. So with these two, and I divide it by 2, I get 512. 512 when it's anything below 512, so 511, immediately our street light system would work. So for instance, this is 511, and then our street light is on. So below 511, rather, that's our threshold for the system. Now, I've been able to demonstrate to you a combined scenario for my project. Let me walk you through the Arduino code. So I'll stop the simulation for now and then move out of this view. So now this is the code. The code has been divided into sections. I have the pin definitions here where each connected to. So we have, let's say, we have the red pin which is connected to pin 8, red is yellow is connected to pin 9, and so on and so forth. We also have the state variables declaring the states that are there. We have the red state, we have the green state, and we have the yellow state as well. And then I have my setup as well, which is input and then which is output. So the red, all the LEDs, of course, are outputs. And then we have the push buttons, which are inputs because they receive input from the user. And we have our loop as well, which shows the update street light and then check emergency as well. I also have my activate state as well, which what kind of situations would activate which state, whether the state 1, state 2, or state 0. And then I have my serial print statement printing out the states over here. And then the traffic state machine as well, which shows conditions. If, for instance, the green state, the vehicle button is pushed, which and green state should be extended. And then if it is pushed twice, it can't extend twice. It only extends one unless it renews again and then a new cycle comes and we are able to get a new extension again. And then we have the street light system, which lights up during the day and then during the night. And we have the print statement as of printing the LDR values, for instance, 568, which means it's greater than our threshold, and therefore the street light would light up. I have the activate buzzer as well, which activates the buzzer when the emergency button is pushed, and then the clear emergency mode after it is released for the system to go back to normal. So basically, this is my entire project on Arduino Uno, and no logic lives directly in the loop unless it is called upon. So we can't say this traffic light system lives in the loop. No, they all work together, and I've been able to make my system. So that's it for the end of this video. And with this, I'll say thank you for watching my video, and yeah, bye.